Hi there, I'm going to tape a video today on Unit 6 practice test. So the first problems have to do with the set of omega, which is the numbers 1 through 10, and then we have subsets A, B, C, and D of omega. So if you look at this first problem, and you have to do these separately, and this could be your number 2 depending on which version you have, and always look to make sure that your answers are right because there's two different versions of this. They're just switched up a bit. So the first situation is I have A union B. Okay, union means I combine those two groups together. So I'm going to combine A and B. So I have a 1, I have a 2 that's actually in both groups, but that doesn't matter. I have a 3, I have a 4, I have a 5, I have a 6, and I have an 8. So that is A and B combined with the intersection now of C, 1, 3, 5, and 7. So now that I have what's in parentheses, my combined group of A and B, or A or B, and then I see, okay, what do they have in common? They have a 1 in common, they have 3 in common, they have 5 in common, so my answer is going to be a set of 1, 3, and 5. The next situation says I have the intersection of A and C not. So the first thing I need to do is I need to find the set that is the intersection of A and C. So I have, so I'm going to kind of ignore B at this point, and so I have 1, 3, and 5 would be the intersection. Well, then it says it's not 1, 3, and 5. So I go up to omega, and I cross out 1, 3, and 5, and then I'm left with, that is my set that I'm talking about. What I'm left with, 2, 4, 6, 7, 8, 9, 10. So your answer is the set 2, 4, 6, 7, 8, 9, 10. Number 3 is also a set problem, but it has to do with Venn diagrams. So I need to find the intersection of X and not Y. So the first thing is I know that this is my X, okay, everything that's in that, and then I have to cross out everything that's not Y. So I'm going to basically cross that out because that doesn't exist. And so I have this situation where my X was 1, 2, 4, 5, and 8. And then my not Y is going to be 1, 2, 5, and 6. And now I have to find my intersection, so that's 1, 2, and 5. So basically we're left with 1, 2, and 5 is our answer. The next one is determine the set that's represented by the shaded region. So this is B and this is C. So I guess I have to go through first and figure out which ones are not true. So if I look at the union of B and C, that's going to be everything that's shaded in both of them, and that is not the case. Again, I have the union of B and C, and then with the intersection of A. So it would be basically this part right here that's not shaded at all, of the intersection of that. So that's not right. The next one is the union of B and C, so everything here, and then the intersection with not A, so everything that's not A. And that actually is the answer because nothing out here. Number 5 is a geometric probability situation. So geometric probability is equal to the area, the favorable area, or the area of the favorable outcome, divided by the total area. And in this case, it says each square below is equally likely to be selected. If a square is chosen at random, what is the probability that the shaded, so shaded is going to be my favorable area over my total area here. So I just start counting my rows, or my shaded. So 1, 2, it would help. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there are 20 shaded squares over a total of 36 squares. So 20 divided by 36 is going to be 0.555 repeatings, which is 56%. So hopefully that helps you with that one. Moving on along to the next page, again, we have the geometric probability. So it's the geometric probability. So we're trying to find the area of the shaded because I want to know the bullseye. So the area of the bullseye over the area of the target. And in my problem, it tells me that the bullseye has a radius of 1 and my target has a radius of 8. So the area of my bullseye is pi times 1 squared, and the area of my target is pi times 8 squared. So basically it ends up being pi times 1 over pi times 64, and so my answer is 1/64. Number 7, it says a die is rolled 10 times. These are the results. The probability of rolling a 2 is 3/10. Which type of probability? We are doing the activity. So we are doing or performing the experiment. Theoretical is in theory. What's supposed to happen? These would be notes that you can write down. What's supposed to happen? Subjective, this is an expert's opinion. An expert meaning opinion, meaning like a weather person. And then random is just randomly out there. So because we're actually doing the experiment and we're rolling the dice, it's empirical or experimental. There are 8 shirts in your closet, 4 blue and 4 green. So there's 8 total shirts. You randomly select one to wear on Monday and then a different one on Tuesday. So this is dependent because what you can wear on Tuesday depends on what you already wore on Monday. And it says you wore a blue shirt both days. Determine whether it's independent, dependent, both, or neither. And it is dependent because it says different. Number 9, it says determine which pair of events A and B are independent. So I know if they are independent. If independent, then the probability of A and B, so the intersection, is equal to the probability of A times the probability of B. So I just start multiplying. And so when I multiply these two out, that's equal to 0.12, so that's not right. Here I have to actually solve for the probability of A and B. So in this situation, I would have 0.4 is equal to the probability of A and B divided by the probability of B, which is 0.2. So in this case, it's 0.4 times 0.2, 0.08. And then when I multiply 0.25 times 0.2, I get 0.05. So that's not the case. And this situation is the same type of one. Let's go on down and see if we can quickly do this. So 0.6 times 0.5 is going to be 0.3, and so that's the independent one. Number 10, Miss Carter has several coins in her pocket, 2 pennies, 1 nickel, 3 quarters, 5 dimes, so 8, 9, 10, 11, so 11 total. If she randomly picks 2 coins at the same time, so that means if I pick one, I can't pick the other one again, or that one again, what is the probability that she picks a quarter and a nickel? So the first one is a quarter, so 3 out of 11, and the next one is a nickel, which I have 1 out of a total of 10 choices, because one of the quarters is already gone. So that would be 3 over 110, so 3 divided by 110, and your answer should be 2.7%. 0.027, and so that's equal to 2.7%. Number 11, it says a bag contains 4 red marbles and 3 blue marbles. You randomly pick a marble and then return it to the bag. So I'm returning it. So this is independent. Nothing is changing. Which expression represents the probability that the first marble will be and the second marble will be red? So probability of red times the probability of red, and because I replace it, it's going to be 4 over 7 times 4 over 7, and your answer is C, 4 sevenths times 4 sevenths. The probability of red times probability of red. Mr. Winsler has a bag of marbles. He randomly pulls out 1 white marble and does not replace it. So pulling out 1 white marble and not replacing it. Then he pulls out a second marble. What's the probability that the second marble is also white? So he pulled that one out already. It's gone. He didn't replace it. So now I have 2 whites left out of 7, so 2 divided by 7 is 29%. Numbers 13 and 14, it says A and B are independent. So by knowing that, I know the probability of A and B is equal to the probability of A times the probability of B, just by saying that they're independent. So I know 1/8 is equal to A times 1/4. So I just take 1/8, 1/8, and then I divide that by 1/4, which is 1/2. So A is equal to 1/2. And then 14, I am asked to find the probability of A and B, and I am given an OR in each probability. So if you look at your formula sheet, you can say, okay, I can use the OR formula, or the addition rule. Probability of A or B is equal to the probability of A plus the probability of B minus the intersection of the two. So I have 0.61, I'm plugging it in at this point, 0.4 plus 0.35 minus, and I'm just going to say that's X. So I add these up, equals 0.61 minus X, subtract, minus 0.14, and is equal to negative X, and then I divide both sides by -1, and so it's equal to positive 0.14. And then the last one on this page, which of the following describes two mutually exclusive events. So mutually exclusive, it means one does not affect the other. One doesn't affect the other. There's no intersection. The other. So rolling 6 on a dice or even, 6 is even, so one affects the other. There would be something to subtract in the OR situation. Rolling a 3 or a number greater than 3, this does not intersect at all because 3 is not greater than 3. The probability that the sum of the numbers rolled is an odd or a sum of 7, well, 7 is an odd number. The probability that the sum of the numbers rolled is even or a multiple of 3, multiples of 3 are 3, 6, 9. So 6 is actually even, so that would not be the answer either. I'm going to save numbers 16 through 25 for the next video.